Hi everyone. Today we are going to discuss about our first chapter from chemistry, chemical reactions and equations. In this chapter, we have to learn about types of chemical reactions. Before that, we should know about physical changes and chemical changes. In our surroundings, we have two types of changes, physical changes and chemical changes. I gave you one example here, the melting of ice. It is a physical change because after the melting of ice, actually ice is a form of water. Ice is a solid form of water. So after the melting of ice, we will get water. And after the vaporization of water, we will again get the water itself. That means there is no chemical change is happening for water. So I took the melting of ice as an example for physical change. We have another example. If we are breaking a glass, it's a physical change. If we are crushing a paper, it's a physical change. So we have a number of examples for a physical change from our daily life. Now I am going to the next precious change. It is chemical changes. Actually, in a chemical change, we have four characters or four situations. In a chemical reaction, the four characters will be happened. The first situation or first condition is change in temperature. In a chemical reaction, there will be an absorption of heat energy or evolution of heat energy. We can say endothermic or exothermic. Endothermic means absorption of heat energy. Exothermic means evolution of heat energy. So, the heat energy may be evolved or absorbed in a chemical reaction. That will be a reason for change in temperature. So, this is the first character of chemical change, change in temperature. We have another character for a chemical change or a chemical reaction. It is change in state. It means if you see the reactants which has a character of solid or liquid or gas, but after the reaction you will get product. That product may be in a different physical state. So for the reactants may be solid, liquid or gas, but what about the products? You can see a change in physical state. If you take calcium carbonate, as an example, now I can take the example CaCO3. If you heat CaCO3, what will happen? You will get calcium oxide and carbon dioxide. Actually, carbon dioxide is a gas, but calcium oxide is a solid, and calcium carbonate is also a solid. It is a chemical change. It is a chemical reaction where the reactant can exist in the solid state. But what about the products? The products are in one of the product, carbon dioxide is a gas, but the calcium oxide is a solid. So I told you, change in state is a character of a chemical change of a chemical reaction. In this example, carbon dioxide is evolving. See the physical state of carbon dioxide, it's a gas. CO2 is a gas. So change in state may be happened in a chemical reaction. The next one is evolution of a gas. We can take the same example. From the same example, we can say there is a evolution of a gas is happening. There is a evolution of gas. Carbon dioxide is evolving here. So, evolution of a gas is a character of a chemical reaction. And I am telling to you the last one, change in color. In many science exhibition, we can see a number of experiments are doing by the students. There is lot of color change. When students are mixing two test tube, having different solutions, they can see. That means we can see a color change. We can see a color change, beautiful color change may be happened in lot of experiments, which indicates a chemical change involves change in color. Again I am repeating the things. The first one, change in temperature, change in state, evolution of a gas, change in color. All are the examples of a chemical change. So I discussed with you the introduction of this chapter, physical changes and chemical changes. After this topic, we will directly go to the discussion regarding to the types of chemical reaction. Next, we are going to discuss about the types of chemical reactions. This is the first type of chemical reaction, combination reaction. Actually, the chemical reactions are classified into 4 types: combination reaction, decomposition reaction, displacement reaction, double displacement reaction. This is the first type of chemical reaction, combination reaction. This is the definition of combination reaction: when 2 or more reactants are combined together to form a single product. It is known as combination reaction. I gave you a simple example. When we burn magnesium, we will get a white powder known as magnesium oxide. Actually, magnesium has an appearance of silver color. So the silvery appeared magnesium will be converted into a white powder known as magnesium oxide. So the magnesium will combine with the oxygen present in the atmosphere, because we know oxygen is needed for the burning of every substance. So the magnesium will combine with the oxygen and we will get magnesium oxide. This is a perfect example of combination reaction. Here you can see 2 reactants when they are combined together to form a single product. This is the condition of combination reaction. We can expect only one product in this reaction. Next, we are going to discuss about the second type of chemical reaction, decomposition reaction. According to the decomposition reaction, when a single reactant breaks down to give simpler products, it is known as decomposition reaction. Again, I am repeating the definition. When a single reactant breaks down to give simpler products is known as decomposition reaction. I gave you one famous example, the decomposition of calcium carbonate. Here, what is happening here? When we heat calcium carbonate or limestone, we will get calcium oxide and carbon dioxide. Calcium oxide is known as quicklime and carbon dioxide is a gas. Actually, we should heat the reactant, limestone. We have to heat limestone to give the simpler products known as calcium oxide and carbon dioxide. So it is known as thermal decomposition. Why it's known as thermal decomposition? Because this reaction is happening by the absorption of heat energy. This delta indicates the absorption of heat energy. This delta indicates the heat that we are giving. The heat we are giving. Okay, so in the presence of heat energy, the limestone is converted into calcium oxide and carbon dioxide. It is a thermal decomposition reaction. Actually, decomposition reactions are classified into 3 types: thermal decomposition, electrochemical decomposition, photochemical decomposition. Electrochemical decomposition reactions are happening in the presence of electricity, but photochemical reactions are happening in the presence of light. Photo means light. So we can classify decomposition reaction into 3 types. The first one is thermal decomposition, which is carried out by heat. The next one is electrochemical decomposition, which is carried out by electricity. The last one is photochemical decomposition, which is carried out by sunlight or light energy. Next, we are going to discuss about the endothermic reaction. When heat energy is absorbed in a chemical reaction, it is known as endothermic reaction. I gave you one simple example here, the decomposition of FeSO4. This is a endothermic reaction. Why this is an endothermic reaction? Because heat energy is absorbed in this reaction. Can you see 3 similar products? The ferric oxide, sulfur dioxide, as well as sulfur trioxide. This is a thermal decomposition reaction. It is also known as endothermic reaction, because in this chemical reaction, heat energy is absorbed. Heat energy is absorbed in this given reaction. So this is a very famous example. Can you see the color is changing here? FeSO4 appeared as a green. It has a green color. FeSO4 has green color, but after the conversion, after the decomposition, the FeSO4 become Fe2O3. It has reddish brown color. It has reddish brown color, and SO2 and SO3 are gases which will go to the atmosphere. Next we are discussing exothermic chemical reaction. The definition is chemical reaction in which heat energy is evolved. See the reaction. What is happening here? After the combination of calcium oxide and water, you will get calcium hydroxide. And after the formation of calcium hydroxide, a huge amount of heat energy is evolved in this reaction. So it is known as exothermic reaction. Exo means evolution or evolving. Thermic means heat energy or temperature. So in this reaction, exothermic chemical reaction means heat energy is evolved. So I take calcium oxide, quicklime as an example. When we mix water with quicklime, we will get slaked lime. It is known as slaked lime. Calcium hydroxide, it is known as slaked lime. Its physical state is aqueous. A huge amount of heat energy is evolved in this reaction. So it is known as exothermic chemical reaction. So we have classified the reaction into endothermic as well as exothermic. Okay. Now we have displacement reaction. Actually in displacement reaction, what is happening, you know, when a highly reactive metal displaces a least reactive metal or a less reactive metal from its salt solution, it is known as displacement reaction. We have a number of examples for displacement reaction. If you know reactivity series, it is very simple for you to collect the chemical reactions which are coming under displacement reaction. I gave you one example. Fe plus CuSO4 gives FeSO4 plus Cu. In this reaction, iron is more reactive than copper. So iron can displace copper from copper sulfate solution. Then you will get FeSO4 and copper. So similarly, we can make a number of reactions by observing the reactivity series. In the top of the reactivity series, you have potassium, sodium, calcium, magnesium, aluminium, etc. So you can choose the most reactive element first. Then you can take a salt solution having a least reactive metal. This is a very famous example for displacement reaction in which iron can displace copper from copper sulfate solution, and you will get FeSO4 and a copper. Okay. So we have discussed combination reaction, decomposition reaction, especially thermal decomposition reaction, endothermic reaction, exothermic reaction. Now we have displacement reaction. Okay. So thank you all. See you soon with another lesson. Bye.